So many chats here. Wow, heavy. Okay. And then this is the Earth. So the gravitation force is an attractive force. I think this is not difficult to understand, to know it. So you should know this force is always attractive. So there's a force acting on Sun by Earth, and there is also a force acting on Earth by Sun. And you should know that these two forces have the same magnitude because they are action and reaction pair. So let me give you the value of the mass of the Sun. So the mass of Sun, does anyone know it? It's 2 times 10 to the power, 10 to the power 30 kilogram. And then the mass of Earth, 6.598乘10嘅4次方 is 5.898 times 10 to the power 24 kilogram. And then the distance between the Earth and Sun, does anyone know it?
1 AU.
Yeah, 1 AU, if you know that unit. But in terms of meter, it's 1.5 times 10 to the power 30.
So is the average?
That is the average distance. So can you find the force between the Earth and the Sun? So we try to get the magnitude of the force acting on Earth by the Sun.
Oh wait, so mass, the two M's are like just basically like the two masses of the planets.
Yeah.
So small m and big M. Okay.
Yeah, the small m, big M are the two masses.
What's your answer?
Let most of the student, let most of your classmates get the answer first. So the force should be quite large, while heavy say is 3.5 Newton.
Newton.
So it's 3.5 times 10 to the power 22 Newton. Does all of you get? And if you get the wrong answer, I think
I did.
You need to care about that. This is an R square. It's not just R. Okay. So and then you know. Okay. Let me give you a chance. Using the force, find the speed of the Earth orbiting around the Sun. Do you know what this means?
Yeah, you can use F equals to mass times radius times angular speed to find out the angular speed, and then you can find the velocity.
So this question actually used the concept in the last chapter about the circular motion. These two chapters are very closely related. So normally the long question in your paper 4 will contain the concepts from these two chapters. So you need to use the concept in both chapters. Not that large band, your speed is greater than the speed of light already. Then the Earth will be so weird.
What's the answer?
So the force equal to mv squared for r. So you have the radius, you have the mass already, so you can find the speed. Yes. So if your answer should be around 3.0 times 10 to the power 4 meter per second. Any question?
Is my answer also correct?
Yeah. And then the small m is the mass of the Earth. mv squared of r is the centripetal force times v squared, and then the r is also given in the question. I think this is not too difficult, is it? Hello. Is it okay?
Yeah.
And then let me give you okay, this is if you consider the orbital motion of a mass m orbiting around a sun with mass m. Show that, okay, you may send, you should do it on a piece of paper, and then you can send the answer in the WhatsApp group. Show that the period t and the radius r has the relation. That is period to power p squared is proportional to the radius cube. Okay, let me give you time to do it. I think 5 minutes is enough. So you try to do it on a piece of paper, and then if you don't know, and then you ask me here. If you want a hint, maybe the only hint I can give you is the gravitational force provides the centripetal force. Then you try to see if you can derive this relation. You need to send me in the WhatsApp group after you have done it, because we need to take the attendance. The school asked me to take the attendance now from now on. So you have the formula of gravitational force already. And then you have the formula of centripetal force. So, and then try to use this concept to show that the radius cube is proportional to p squared. you may need to go back to your textbook and to have a look at the formula for the centripetal force. You take a photo and then send me in the WhatsApp group.
Sir, I think I got.
Ah, sorry. Hello.
I think I got it.
Uh-huh. Finish. Harry, you get many mistakes in the formula.
So many mistakes.
But Iris' answer is correct, so there's no problem.
So my
But for the others, you get it correct, but I'm not sure why you have M1, M2, and big M.
okay.
But how about the others? Actually, this is a past paper question now to ask you to show it. So first of all, the formula for the confrontational force is GMM over R squared. And then the formula for the centripetal force of the small m should be m, use m armor squared. Because I can get the period directly from the omega. That is 2 powerful period. Okay. If you can't get the answer, and then you can still try it. So let me give you 1 minute left. So if no question, and then let's go on. So let's go on. What do you mean by explain further? Like make a mistake? You forgot. What do you forgotten?
Wait, sir.
Uh-huh.
Sir.
Uh,
Is
what would you like to ask? Hello?
is MV square over R the same thing as MRW square?
Yeah.
Okay.
Actually, in the past paper, they also asked you to find the you need to find the constant, proportionality constant in this formula. So let me rewrite the formula. Okay, this one. And actually, this formula has also a name for it. Does anyone know what's the name for it? Hello, anyone know? No.
Mm,
Hmm? Hello. Anyone knows? No. 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 Okay. Affirmation law, if you know.
Is there a word ratio?
No. So this is also called capacitance.
What
Actually,
is that?
so this is a very famous law in astronomy, and then you can use this formula to find the period if you are given the radius. So actually, what you can see from okay. Actually what you can see from the video that's shown before in the software universe samples. Wait, how can I delete it? Why there's no effect when I press delete? And then from this, what is the big M in this formula?
Mass.
Which mass?
Sun.
Yeah, that's the mass of the sun. Or that's the mass of the object that is stationary. So, and then, let me give you some knowledge. So actually,
Sir, what if none of them are stationary?
if it is a binary star, so, and then this formula does not apply. If you see this symbol in astronomy, the big circle with a dot, that means a star. But that means the sun. This one, that means the earth. That's the astronomy symbol to be used in. This is a
Moon.
yeah, okay. So let's go on. So is it difficult? Hello, is it difficult?
It's okay.
no.
It's okay.
Yes, sir.
Okay, let me show you a video.
Again.
That's another very famous law. So let me share my screen. Oh, so I need to stop recording.